Hey everybody, how's it going? We are going to continue right along here with our lessons with regards to light and how it interacts with reflective surfaces like mirrors. So before we start the actual meat and potatoes of this particular lesson, we are going to learn a little bit about the anatomy of a curved mirror ray diagram. Because there's a lot of components to it, and I want to make sure when I'm talking, you guys know exactly what I'm talking about. So like plane mirrors, curved mirrors have to obviously obey the law of reflection that you guys learned above. In other words, when we have a reflective surface here, we have some incident ray coming in at some angle measured off of the normal, which we call theta I. When it strikes that reflective surface, it will reflect off that surface at an angle theta R, where theta I is equal to theta R. For those of you who maybe can't hear exactly, the way you pronounce this symbol is theta, and it's spelled, if my pen will start working here, there we go, Theta, theta. Okay, so when I'm talking about theta, I am talking about an angle there. And of course, this is my reflective surface, and this side of the mirror there is not reflective. With a curved mirror, nothing changes, still has to follow that same rule where theta I equals theta R. The only difference is that it's going to be a different angle depending on in which direction you are coming at the mirror and where on the mirror that particular light is striking. So I'm going to draw out a curved mirror ray diagram to help us out here. So here's my curved mirror. Now, this particular mirror is going to be reflective on the inward side, and this is what we call a concave mirror. We will do the opposite to this, where it flexes outwards and is reflective. It's called a convex mirror. We'll do that a little bit later. There is a line that travels. Now, of course, you'll be using a ruler when you're doing this. There's a line that does travel and where it hits this particular mirror, it hits at a 90-degree angle. We call this line here the principal axis. And so if it strikes at a 90-degree angle, if you have a light ray that's going at that, like in line with that particular line there, then you are going to strike that mirror at 90 degrees, which also means you're going to bounce off at 90 degrees. Now, where the mirror crosses the principal axis, we call that point the vertex. Okay, so the vertex is the middle point of a curved mirror. It's also where the principal axis crosses the mirror there, and that hits at 90 degrees from there. It's a perpendicular surface. Every mirror has a level of twist to a level of turn or curvature. If I were to continue drawing this mirror around, as I'm showing you with these dotted lines, it would eventually make a circle. Where that circle is created, the center of that circle, let's pretend it's there for right now, the center of that circle is what we call the center of curvature. And it's denoted with the letter C. So you won't see me writing out center of curvature, you'll just see a C distance there. Now that's not to say that that it's going to be at this point all the time. It depends on how curved that particular mirror is. It could be closer to the mirror or further from the mirror. What we ultimately get from that is at half the distance. So, you know, it's about half the distance to the mirror there. I reach another point that we'll label F here, and that's called our focal point. And the focal point is really, really, really interesting because when light rays that are traveling parallel to the principal axis strike the curved mirror, they will all reflect to that focal point. What do I mean by that? Well, I'll redraw another one so I can actually draw these lines here. If this is my curved mirror and this is my principal axis, I'll label everything here. I have vertex. Let's say I have my focal point here. Let's say twice the distance, somewhere around here, I have my center of curvature. If I have light rays that are traveling parallel to the principal axis, if I have light rays that are traveling parallel to the principal axis, as these ones all are. When they strike the mirror, they strike it at such an angle that when they reflect backwards, they always reflect to that focal point. So you remember the other day when I was telling you guys the lesson regarding how these light rays bounce off. That focal point focuses all of the light to that one single spot there. Okay, and so that's why we call that the focal point. It's the focus. It's where light gets focused all together, and that's based on parallel light rays traveling towards the mirror, striking the mirror, following the law of reflection that we had seen up above and from the previous lesson, and ultimately bouncing towards that focal point. And these are all parallel to the principal axis. So that's the anatomy of a curved mirror ray diagram. The subsequent lesson is going to actually be looking at these particular ray diagrams and actually getting an image and describing it using LOST. So I'll see you guys in a couple of minutes.